Welcome to question 4 of the 2012 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 4 we have that on any given day the number x of telephone calls that Daniel receives is a random variable with probability distribution given by the following table. For part A we're asked to find the mean of x. And from our formula sheet, we know that the expected value, or the mean value of x, is equal to the sum of x times p of x. So therefore, for this question, the expected value of x, or the mean, is equal to x times p of x is 0 times 0.2, plus 1 times 0.2, plus 2 times 0.5, plus 3 times 0.1. And now that's equal to 0 plus 0.2 plus 1 plus 0.3. And that simplifies to 1.5. So the mean of x is 1.5. From the examiner's report we can see that this was generally well done, with 82% of students getting the full mark for that question. Some students either did not answer this question or went about determining the variance, median or some other parameter rather than what was asked for. Other students knew that they needed to multiply each value of x by its probability and add the terms, but either could not do that correctly or divided their result by 4, which is not required as part of the calculation. For part B it asks, what is the probability that Daniel receives only one telephone call, and the probability of that occurring on any day is 0.2, on each of 3 consecutive days. So the calculation for this is going to be 0.2 times 0.2 times 0.2. So that's the probability of getting exactly one phone call on each of 3 consecutive days. And that is equal to 0.008 when you evaluate that. So that is the answer to part B of this question. Now, if you're not as confident with decimals, this calculation could have been done using fractions. So 0.2 is the same as a fifth. So you'd have 1/5 times 1/5 times 1/5, and that would equal 1 times 1 times 1 is just 1 on the top line, and 5 times 5 times 5 gives 125 on the bottom line. So that would have been an equivalent answer as a fraction. So for part B of this question, the examiner states that most students knew they needed to evaluate 0.2 cubed or similar, but students were not able to evaluate it correctly. Only 60% of students got the mark in this exam. For part C, we're told that Daniel receives telephone calls on both Monday and Tuesday. And we are asked, what is the probability that Daniel receives a total of 4 calls over these 2 days? So the first thing that we can see is that they have actually made this a conditional probability question, as we know that he has definitely received at least 1 call on both Monday and Tuesday. So this question, we can now distill it down into a conditional probability, and it is the probability that he receives a total of 4 calls, given that he receives calls on both days. And now we can work that out as being the probability of him getting a total of 4 calls, given that he has a call on both days. We could split that into the events that he gets 1 call on Monday and 3 calls on Tuesday, plus the probability that he gets 2 calls on each day, plus the probability that he gets 3 calls on Monday and 1 on Tuesday. And now we have to divide by the condition, and that condition is that he receives calls on both days. So the probability that he receives at least 1 call on any given day is 0.8. So we can do 0.8 times 0.8 to represent the probability that he gets at least 1 call on both days. So this is then going to equal the probability of getting 1 call followed by 3 calls is the probability of getting 1 call is 0.2 times the probability of getting 3 calls is 0.1 plus the probability of getting 2 calls multiplied by the probability of getting 2 calls plus, and then we get the probability of getting 3 calls on the Monday and 1 call on the Tuesday. And that is still divided by 0.8 times 0.8. And now our job is to evaluate this fraction. So this is equivalent to 0.2 times 0.1 is 0.02 plus 0. And this is going to be 25, and then we had plus 0.02, and then that is all divided by 0.8 times 0.8, which is 0.64. And now one more step of simplification, we'd have 0.29 over 0.64. However, we don't mix decimals and fractions, so we're going to write that as 29 on 64. So that is the answer to part C of this question. And from the examiner's report, we can see that most students were not aware that the condition of receiving telephone calls on both Monday and Tuesday would affect the result. So they weren't aware that some sort of conditional probability was taking place. A significant number of students incorrectly thought that 2 calls on Monday and 2 calls on Tuesday was different from 2 calls on Tuesday and 2 calls on Monday. And it goes on to say that students who use a key or a tree diagram were less likely to make this error. And now if we look back to the proportion of students who got this question correct, only 3% got the question fully correct, with 41% of students getting 0 marks for this question.